Alright, hello, good evening. First of all, let's have a look at the solutions to the homework of topic 12a. Okay, first question. Points PQR are on circle O such that PQ is 78 degrees, QR, sorry, there's a typo here, should be arc QR is 123 degrees and arc PQR is 201 degrees. Okay, first of all, it's better to draw a diagram to illustrate the situation here. And we're asked to find the following angles. Okay, first angle QPR. So here, angle QPR is inscribed in arc QR, right? So its measure is simply a half of the corresponding arc, which is arc QR, right? And this gives us 61.5 degrees. Then let's find angle PQR. Angle PQR is inscribed in arc PR, right? This means it has a measure of 360 degrees minus 201 degrees, which is 159 degrees. That's the measurement of arc PR, and sorry, this should be arc PR. And then we know angle PQR is inscribed in PR, which is 1/2 of PR. And that gives us angle PQR is 79.5 degrees. Okay, the third one. Okay, angle PRQ. Angle PRQ is inscribed in arc PQ, right? So simply angle PRQ is just 1/2 of the arc PQ, which is 39 degrees. Okay, the next one is to find angle POQ. Angle POQ is simply the arc PQ, which is 78 degrees. And question E. Okay, first of all, we know PO equals QO, right? And then triangle POQ is isosceles with angle PQO equals angle QPO. And from this triangle, we have angle POQ plus angle PQO plus angle QPO equals 180 degrees, right? Therefore, we have angle PQO equals 180 minus angle POQ divided by 2, and this gives us 51 degrees, right? Okay, then last question, question F. Angle POR is simply the measure of arc PR, which is 159 degrees, right? Okay, so have a look at the solution here. Any questions, just let me know, okay? Alright, if no questions, let's have a look at the second one. So this time we have points points R and S are on circle E. So first of all, let's draw a circle E. The center is point E, right? R, S are on that circle such that the arc RS is 50 degrees, so 50 degrees is here. Point T is also on E, so where's point T? T could be here or here, right? For angle RTS to be an angle, T cannot be on top of R or S, right? So first of all, if point T is on minor arc RS, that means T could be here. Then this is our angle RTS, right? So in that case, angle RTS is inscribed in major arc RS, which is this arc here, right? So let's say if point T is on minor arc RS, the angle RTS is inscribed in major arc RS, which has measure 360 minus 50, which is 310, right? In that case, angle RTS is simply 310 degrees over 2, which gives us 155 degrees, right? Otherwise, there's another possibility, which is here. T could also be here, right? In that case, that's our angle RTS here. So if point T is on major arc RS, which is a longer one, then angle RTS is inscribed in minor arc RS, right? In that case, angle RTS is 50 degrees over 2. This is a simpler case, which is 25 degrees, right? Therefore, our possibilities for angle RTS possible values of angle RTS are 155 degrees or 25 degrees, right? Okay, good. Then let's have a look at the next one. Question number 3. Points E, F, and G are on circle O. Okay, let's draw a circle O. Suppose this is point E. There's another point F and G. Such that EFG is 48 degrees. GEF is 78 degrees. So we have 3 questions. First, find angle EGF. So this is simple, right? Because angle EGF is simply sum of all internal angles of that triangle EGF minus angle EFG minus angle GEF, which gives us 54 degrees, right? Okay, second question, the measurement of arc EG. So basically, that's the central angle here, right? That's the measure of the arc EG. So we know that angle EFG is inscribed in arc EG, right? So we have arc EG is simply twice of the measurement of angle EFG, and this gives us 96 degrees, right? Okay, then question C. So it can be easily seen that angle EFG must be less than 90 degrees, right? We know that F is on major arc of EG. Okay, so we found that minor arc EG is 96 degrees in the previous part. Therefore, we have EFG, the longer arc, is simply 360 degrees minus the minor arc, 96 degrees, which gives us 264 degrees, right? Okay, again, have a look at the solution here. Any questions, just let me know, okay? Alright, if no questions, let's have a look at question number 4. Okay, we have a diagram on the right, and we're asked to find the following angles or arcs and prove some statements. Okay, first let's consider question A, angle D. So angle D here is inscribed in the same arc as angle C, right? So angle D is simply equal to angle C or ACB, right? And both of them equal 1/2 of arc AB. So we can simply say angle D equals angle ACB, which is 36 degrees, right? This is very simple. And second question, arc AB, which is a shorter arc here. Otherwise, you should use another point here to denote the longer arc, right? So the shorter arc AB, again, it's simply twice of the angle D or ACB, right? So that gives us 72 degrees. Okay, question C. Find angle ABF. So ABF is here. So we know that angle ABD can be calculated using arc AD over 2, right? So that is 180 degrees minus arc AB, then over 2. And we know arc AB is 72 degrees, so that gives us 54 degrees. And we have angle ABF is simply 180 degrees subtracted by angle ABD, right? And that gives us 126 degrees. Okay, next question. Find angle EFB. So EFB is here, right? So we could make use of the right triangle EDF. In that triangle, we know angle E, we know angle D, so angle EFD is simply 90 degrees minus angle D, which gives us 54 degrees. Okay, next question E. Find the measure of CD. Arc CD is a minor arc here. So combining the conclusions from part C, which states angle ABD is 54 degrees. And the conclusion from part D, which states that angle EFD is 54 degrees as well. So we know angle ABD (54), angle EFD 54, right? As you can see here, that indicates EF. Oh, sorry. That's question F. We haven't finished question E first. Okay, let's finish question E first. So in that question, we need to find arc CD, right? Arc CD is simply angle, the central angle COD, right? And that is angle AOB because they are vertical angles, which equals the measure of arc AB. We already solved arc AB, which is 72 degrees, right? So arc CD is also 72 degrees. Okay, then let's consider question F. Prove these two segments are parallel. As we can see here, we have already proved angle ABD equals angle EFD, which are both 54 degrees, right? Therefore, we have EF is parallel with segment AB, right? Okay, then last one. Question G, we need to prove AD equals BC. So we can make use of a pair of congruent triangles. So we can state that BO equals AO, right? Both of them are ready of the circle. And also we have CO equals DO. Also angle BOC equals angle AOD, right? Therefore we have triangle AOD is congruent to triangle BOC by SAS congruence. Therefore corresponding sides are equal. So AD equals BC. You get it? All right, then let's have a look at the last one. Arc WX and YZ of circle Q. Okay, first let's draw a circle. We have two arcs WX and YZ. So there are two cases. We need to consider two cases, right? The first is we could have W here, X here, and Y and Z. Something like this. So in that case, the two arcs do not intersect, right? So let's say case 1, the arcs do not overlap. So let's connect these points. In that case, we have, because we have arc xw equals arc yz, then we have angle wzx should equal 1/2 of the arc wx, right? And that also equals 1/2 of arc yz, and that equals angle ywz, right? So we have shown that angle wzx equals this angle here, ywz. Therefore, we can say segment wy is parallel with segment xz. Okay, now let's consider a second case. Image, the arcs overlap. So we could have w here, x here, and then y here, and z here. Again, let's connect these points, yz and wx. So case number 2, the two arcs overlap. So in that case, we have arc wx equals wx minus xy, right? Oh, sorry, it should be wy. Arc wy equals arc wx minus arc xy, and equals yz minus x arc xy, right? And this gives us x arc xz. So we have also proved arc wy equals arc y xz. From this point, we can follow essentially the same proof as in the first case, right? Therefore, following essentially the same proof as shown in case 1. We have segment xy parallel with segment wz, right? So you need to consider two cases here. Alright, so basically that's the solutions to the homework of topic 2, part A.